Let's find the longest palindrome of a string S. So the longest palindrome is just taking all the letters in a string and then rearranging them so that a longest palindrome can be built out of as many letters of the string as possible. So for this example, we have string equals to this. And from this string, we can extract 7 characters that can make the maximum valid palindrome or the longest valid palindrome. These are the companies that asked this question, and let's get started. The approach I'm going to have for this problem is to first get a map or a dictionary of the frequency of each letter in the string. So for each letter, it's going to give a number of how many times it appears in the string. And from there, I can use that as an advantage. You can do this easily with the counter function in Python. So I'm going to make a variable called sCounter, and I'm going to say equals counter of s. And this basically makes a dictionary of the frequencies of each letter. So if there's one A in S, it'll have A is 1. There's 4 C's in S, so it's going to have C is 4, and so on and so forth. And I missed an N here. The next step, logically thinking, is if there is an even number of frequency for a letter, that means we can use all of the respective frequency in the palindrome. So for example, if there's 4 C's here, we know we can just use these 4 C's and mirror them when we're making the palindrome so that 2 C's are somewhere on this side and 2 C's are somewhere on that side. So they can be anywhere on their respective sides. But the catch is if we have an odd number of characters, that means we can't use one. So we have to basically subtract that character from our frequency when we're adding it to the longest palindrome count. So I'll make a variable called longest and set that to 0. And I'm going to iterate through the item. So that will get both the key and the value. So for key value in sCounter dot items, I'm going to set longest plus equals to value minus value %2. So this means that if there is for example, if there's an extra C here making the frequency count odd, it's just going to subtract one of the C's because we know we can't use it. But you might be thinking, what about the palindromes that are of odd length? And that is a valid concern because if it's of odd length, you can basically have any character you want in the middle. So to account for that, I'm going to make a variable called extra, and this is going to be a Boolean. And first I'll set it to false. And in this iteration, I'm going to say extra equals value %2. So now we're going to set extra equal to true if any one of the frequencies in the sCounter is odd. So that means we can just pull an extra character from there and add it to a middle, making an odd palindrome. And in the end, I will return longest plus extra. And extra will just evaluate to 1 if it's true, else it'll evaluate to 0. So we're basically doing longest plus if there is an extra, if we found an extra remainder in here somewhere. And afterwards, we don't want to set extra back equal to false if we encounter a frequency that's even. So what we can do here is just say if not extra, then we will change the extra value. And that's basically it.